A new 6-mile, 63-inch HDPE wastewater pipeline is now protecting and refilling the Great Salt Lake. It was needed because in addition to decades of water loss, the shrinking Great Salt Lake faced another grave situation: algae. The buildup of algae in the lake's Farmington Bay area was nurtured by treated wastewater from a nearby plant. To defeat algae growth and add more clean water to the lake, the North Davis Sewer District decided to construct a 6-mile, 63-inch diameter pipeline. This would redirect effluent to the lake's Gilbert Bay area where algae could not grow, and make it possible for the lake to receive the much-needed water. The North Davis collection system consists of nearly 100 miles of sewer lines, and it treats up to 34 million gallons a day. Instead of a new treatment plant, the design engineer recommended that a pump station be built with a pipeline to take the treated effluent out of the main body of the lake. This would save $450 to $550 million. The solution, however, faced its own set of obstacles. The new pipeline would need to provide high flow capacity, be able to be buried in unstable soils, withstand the corrosive high salt content of the lake and soil, fight seismic shifts and liquefaction, and provide a cost-saving solution as well. A tall order that was met by using 63-inch diameter PE 4710 pipe as a monolithic line with leak-free joints all along its 33,000-foot run, coming in 40 and 50-foot sections from a pipeline plastics plant in Texas. They were heat-fused on-site using a McElroy MegaMac 2065 fusion machine. ISCO Industries coordinated delivery of the pipe with Pipeline Plastics and handled the complex fabrications at its Kingman, Arizona facility, transporting the completed pieces to Utah. The undertaking earned Pipeline Plastics the Project of the Year award from the Municipal and Industrial Division of the Plastics Pipe Institute.
The North Davis Pipeline Project utilized HDPE pipe for the movement of water back into the Great Salt Lake, needed for not only nutrient levels, but also to meet the requirements by the state. The corrosive nature of the caustic soils led to the selection of HDPE pipe, given its non-corrosive nature. This was the main attribute utilized for the North Davis Pipeline Project.
The design engineer, Mitch Dabling, said that the Great Salt Lake is 8 times saltier than the Pacific Ocean, and anything metal would rust and corrode very, very quickly. Plus, this is a seismically sensitive area, and HDPE being butt fused gave us more confidence that it would be able to withstand a seismic event. The PPI Division's Municipal Advisory Board, MAB 9 document, provides the basis for determining the proper wall thickness for a fused, highly ductile, flexible HDPE water pipeline in a seismically sensitive area when subjected to an induced lateral spread. The DR26 pipe with wall thickness of nearly 2.5 inches was selected to provide structural stability due to the poor soils of the lakebed. The pipe has a working pressure rating of 80 psi, significantly larger than the system requirement of 50 psi, with an additional 80 psi surge pressure capacity. According to PPI, there was another benefit: the reduction of CO2 emissions. This was due to the Pipeline Plastics' ability to make the 63-inch diameter pipe in 40 and 50-foot sections instead of the traditional 20-foot sticks like many other types of pipes.
To ship the 63-inch pipe, we were able to ship 90 feet on a truck rather than the traditional 40 that some other materials could do. And by doing that, we limited the number of truck trips it took to get on site. So we eliminated 400 truck trips on site, which according to the Green Freight Handbook, a fully loaded flatbed emits about just under half a kilogram of CO2 per mile. So if you add all that up, we eliminated over 180 metric tons of CO2 emissions just from truck traffic alone. So that greatly enhanced the environmental aspects of this just from the shipping costs. You couple that with a reduced amount of equipment that's needed to move the pipe around and install it, and the overall carbon footprint of this project by using polyethylene was drastically reduced.
Details about this project can be found in the Wastewater Digest article. Additional information can be found at www.plasticpipe.org/mabpubs.